of you are here to learn about the Zend framework a little bit and how you can send push notifications from it. So let's do my little housekeeping slide that you may have already seen depending on which talks you attended today. The slides will be online later. Software engineering manager at Bridge. We built Bridge websites. I also organize the Minnesota PHP user group. We're always looking for people to talk and attend and do fun stuff because I don't like talking all the time. Irrespective of how many talks I do today, I got a little excited. Open source contributor, I contribute to the Zend framework, which is kind of where the Zend mobile thing came from, for sending push notifications, and a bunch of various others, depending on if I find a bug in it or if I just don't like how it's working, but I don't want to, do all the plumbing myself. That's about it. So you can find me on Twitter, Google+, IRC, my blog that never gets updated, and GitHub, which you'll probably see more commits to. All right, moving on, right? Here we go. What we're going to talk about today is an overview of push notifications in general. So we're going to just go through the protocols, how they work, go through the servers, and everything else related. Then we're going to go over the Zend framework library itself that is going to be in there fairly soon. We're going to talk about Android push notifications, which is C2DM, Apple push notifications, APNS, Microsoft push notifications, MPNS, BlackBerry push notifications, which isn't in the library, but they deserve their own little spot on my slide anyway. And I really don't like BlackBerry, and I really hate their developer relations. FYI. So what are they? What is the benefits? At a high level, how do these things work? All push notifications. They're a message that's pushed to a central location and then delivered to you at a very high level. They're often the same thing as a pub-sub model. You basically just have an intermediary, your phone subscribes to one, and you're publishing it to the subscribers. Pretty easy. The mobile space, they're just technologies, alerts, tiles, raw data, depending on how you leverage them on any platform that you have. Different platforms do different things. Main concept's all the same. Some pictures into a wonderful little BlackBerry. I tried to hide it as good as possible. That's a push notification from BlackBerry, by the way. Little speck dot. Got Windows tiles, get your alerts, which is more general in iOS, and then they now have that wonderful, cool push slide thing that Andrew has. We had first. Yeah, pretty awesome. I like Android. I like Android a lot. It's open. They don't want me else. Anyways, benefits push notifications. There's a lot of them. If you have an app and you're running services to pull for data, you're probably doing it wrong. So I don't know why you do it anyway. So if you're polling, this is what you're doing to that person's phone. They're angry, they post a message to your thing, you're killing my battery.
You're one of 17 apps that are polling.
Yep, one of 17 apps that are polling, and when they launch the app, they realize that my battery life is drained half. They're polling too often. So Google did this wonderful thing of showing you how the impact polling does on the battery. This is when you poll. This is what it's doing. C2DM is already running, and it's running at that level. So the marketplace already has a connection, so why aren't you leveraging it? It's the same way that the App Store in iOS works, is it's actually just underneath the covers, automatically polling their servers already. So they just basically built a bridge for you to do it. So push notification service is very, very efficient, specifically for that reason. It's already there, it's existing, you don't have to do much, it already runs in the background, and your application is going to receive the message. The other part of this is, if you implemented it otherwise you're polling, it's going to waste battery life, it's also going to waste their bandwidth. So one note on this is, say you're Twitter, you're not going to want to use push notifications. Maybe for mentions, you could use them. Maybe for a direct message, you could use them. But you're not going to want to try to update that person's live stream with a push notification, because if you're following a million people, your battery's toast at that point. You have way too many messages going. So generally speaking, they also have a hard limit of how many you can send, and so that's another reason why. So at that point, you have to use polling, but most of us are okay with Twitter polling. Because the other apps that don't really need to, that barely ever messages anyways, that we don't really care to have to do that. The next question we have to ask ourselves, can we deliver? Can we deliver our message? Where's the message going? We don't want to get lost in transit all the time, do we? Well, That's the risk you take when you actually implement push notifications. Most of the time, you're never going to lose a message, but they do not guarantee that your message will be delivered. Probably just to say that you can't sue us if your message is very important and didn't get there. So when you talk about delivery, you're generally polling every 15 minutes if you implement into service. When we send out push notifications, it generally happens almost instantaneously, 1 to 3 seconds max. I've never had one actually go slower than that after I sent it to the main servers. Now, on another side, push notifications can get sent to a device when it's offline, whereas if you have a polling service, you can't. So, yeah. Anyways, again, if you can hit quotas, some notification servers only allow single messages to be in a queue at one time. Some group them by a collapse key, other ones group them by an ID identifier. They're all basically things. If we see the same message, we're probably not going to deliver it twice. And if you have the same collapse key, it won't happen.
That would be from one sender to one receiver at one time?
Yes.
I mean, I could push 7.
Oh, you can push as many as you want all at the same time. It's just you sending it to that individual device. And most of the time you can get by sending multitudes to the device, but the one thing that they say is to be careful of is that they can remove a message at any point directly. We had a deliverability issue at one point. I'll get into that at some point. So all these things work. 10,000 foot view of all these technologies. Device messaging, which is Google's. You have an app server, that's yours, right? So you have the CPDM message front end. So we're basically just sending it up to their server. They store it in the database, hits their connection server, tells the device app to wake up. It sends your message into the app. You can process the response with whatever you need to. If you want to post a notification, you can. If you just want to synchronize stuff in the background, so you send it a bunch of IDs, hey, some stuff is updated, go fetch it and go pull it back into the app and update all the application stuff. You can do that too. So, pretty cool technology. It's really fun. Apple push notifications. Yeah, I can see I stole that from the documentation. I mean, I can't make it that pretty. The provider sends the notification, Apple push notification service receives it, they send it to the phone, the notification gets sent to the app. Then you handle it within your application appropriately. Now, they made this diagram really confusing, and it's really not. But it's the Microsoft way, right? So if you have a push-enabled application, you get a push client service. That push client service has a negotiation with MTNS. It sends you back a URL that you can actually post to, and at which point you're going to send it over to your application, say, hey, register this URL, because I'm sending it to a distinct URL. And then I can send a message to it, and it will be either a tile message, it'll be a toast message. I continue to forget what the other one is because I never have to use it. I just make sure that it all worked.
We still get this all done in 1 to 3 seconds?
Yep. Well, you can't get the whole part done, right? I mean, when your application launches on any one of these, you actually register the device with the server for the push notification server, and then you send that back to your actual application so you can send devices, your messages to the device whenever you need. So that's usually on registration of your application. Here's how BlackBerry works. Now, notice they have an enterprise component of this on the feedback message, which is not generally all servers. So you have a push API server, you hit the data services, you can get the thing, you can send it back to your content provider, store whatever URL or whatever it is. I've been unsuccessful in never getting a BlackBerry app to build, so, which is why I don't know how to make it actually work fully. I modified somebody else's code to make it look like it should work, but I don't know if it does. So, with that, we're just going to talk a little bit about the Zend Mobile Push. This is a component that I had created in November. I was irritated with some of the other libraries. There's a PHP one called APNS PHP, which has this wonderful fascination with attempting to reconnect and cluttering up all of your messages. Your messages never get sent, it just constantly tries to reconnect until you take action on it. That wasn't ideal. It happened to us once or twice, and I was really pissed off about that. There was no PHP library for C2DM, so I wrote one for that because we needed it. And then MTNS, I was like, well, I've got those two, and I want to get this into the framework. And Microsoft, pretty nice to their developers, and you can go to the Microsoft website and actually download sample push applications that give you the URL so you can write something for it. I was like, wow, BlackBerry could do something like that. I might actually get something done on it, but yeah, that's not going to happen. So you can send APNS, E2DM, and MPNS. You can get it on GitHub. Otherwise, right now, you have to get it. It just got committed to their trunk. I think I committed that a week or two ago. They weren't sure at one point if they were going to do another Zend framework 1.x release, and now they're going to do a 1.12 release once all the unit tests pass again. There's a lot of things that we backward in the Zend framework too. That's a little bit about Zend framework. That is for you. If you're going to set up this library, it's pretty easy. SCN, check it out from Zend framework or grab it through GitHub. Make sure you have Zend framework 1 downloaded from the website, or just download the entire thing. You don't have to use all of Zend framework to use this component. The difference between Zend framework and most other frameworks is it's really a component library, but it can be an all-encompassing framework if you want it to be. So that's why it's a pretty nice way to use it, because it's much like Pair in the ability that you can just take some packages down and leverage it. You just need to understand the internal dependencies if you're going to cherry pick them off the source tree. And so I would just recommend pulling down the entire thing so you can leverage it that way. So once 1.12 comes out and released, you won't have to do any more crazy crud work, and you can just download the full package. It won't be there. All right, so now that we got an overview on all that stuff, we're going to talk about Android first, because I like Android, and iOS in second place. And if you actually look at statistics, it is, except when you look at statistics for the App Store. So you can't make money on Android, but you can make money on iOS, so it all works. So when we look at C2DM, Cloud Device Messaging, it allows third-party application services to lightweight message to their Android devices. Notice the word lightweight in there. They want to enforce that these messages are lightweight. You don't want to send a full-blown document through their push notification service. The idea is that you send the message, and then you go and fetch what you need to after you get that message.
So we're talking about 20 bytes, something like that? Or?
I will get to that here for you. I think it's on the next slide.
All right.
Actually, they make no guarantee about delivery or the order of messages. Generally, it's FIFO. It might not happen FIFO, and it might not happen at all. The application running an Android device doesn't need to be running. It does not provide a pre-built interface that just handles the message for you. It requires a device running Android 2.2 or higher, and it has to have the Android market installed.
My app that isn't running will start when the message comes in.
Correct. So the biggest thing about this is 2.2 introduced this. The Android market actually handles all of the push notification data that comes through. So, oh wait, no, Google Play.
That Play thing.
Google Play. Sorry, Debbie branded it on me. I forgot about that. But anyway, that handles that. So if you're using like an Amazon Kindle device, you're not going to get push notifications. You don't have them. Amazon didn't implement anything for you to send them, so you can't have them. So it uses an existing connection, that's why it's more efficient, it doesn't pull your battery all the time. First things first, you have to sign up for an account. Right now they say it's in beta, and the future of it is, they don't know, but they're going to continue to support it. Everything that the Google engineers say, and they're implementing things like that.
You're saying that the person who's pushing the stuff has to sign up for an account?
Yes. You, as in whoever developed the app, you can have a company account. You don't have to have like a specific app account for each one. You can have a company account, but then you send out the device ID, the application ID that you're sending to. So that's how it knows.
Once they download the app, they're going to do it.
Yeah. Once they open up the app and register their device with your service. Yeah. Simple enough. Mobile app registers to C2DM. It gets back a registration ID. From that, you pass the registration ID to your service. So that's the simple flow of how you actually know which device you're sending to. How the application works, you have to update the manifest file. So if you've never seen an Android manifest file, your eyes might get a little bloody and you might hurt. They're not fun, but they're needed. And then you have to create a broadcast receiver that will receive the messages and the registration. Well, that's a little fuzzy. I should have updated that. Anyways, you can still see it a little bit. I mean, come on. So basically, this is the manifest file. I try to bubble it down. The most important piece of this is the D2D message and the permission.receive. You also need an internet connection in order to do it, and you also need the permission to basically have a receiver to second send. And that's basically your send, receive, registration, and that's how everything works. Now this is all documented also there, and if you're going to do it, you can read it up there. So handling the registration or not, this is the very quick and dirty way of doing this. You got registration, you grab it, you put the extra in there, you say, your sender, and this is the email of you, right? So it's your application, so you have to send out your ID up to Google, and it has to be a Google ID. You also have to save your app. Android doesn't have a policy on letting you unsubscribe from push messages. Most of the other ones do, but there's no explicit policy. There's an implied policy, right? You should allow them to unregister. So it'd be nice, let them do that, so that they don't get really angry at you and uninstall your app. They don't think that's what you want them to do. That's even worse. Anyway, so I wrote a whole blog post about this. This is before I had Zend Mobile Push. I created a C2DM library specific for Google, which is what this blog post references. But I had all of this information in there, and that's probably why I copied it weird, and now it's all grayscale around it. But anyways, I mean, simple. You'll find a lot of code examples online, and that's very Java. So, cool. Limitations, what I was talking about. Send 200,000 messages a day by default. Use them wisely. You can request more if you need to. What Google is going to look at, if you do request more, is are you abusing the push notification service for any reason? Why do you need more messages? Should you be
Sending
these
3,000 link message to get a word file across.
Well, you only have 1K message, so you're not going to get that out. So, yep. 1 kilobyte sends all your data, which is pretty generous, much more than APNS can give you. One note, you have to implement exponential backoff. They're going to send a reply to you if you need to start backing out their service, and exponentially you have to get slower and slower and slower and slower. So you might want to make sure your application can handle that and not everything stacks up in memory. Server working, you have to do a client login. So that's up in your service. You're basically logging into C2DM. It can give you a CAPTCHA, and so you have to echo that out and go enter it manually. So you'd want to notify yourself that this is running as a background task. They're not going to generally ever ask you that unless they're seeing a lot of odd results coming in. We've never got to ask once, and we've been sending them out for a year and a half or so. So you basically send the message with the registration ID, the message gets sent to the application, and you're good to go. So this is how you do it with the Zend Mobile Push. They're basically all encapsulated. They don't have much going on in there. Basically, we have a G-data, which is already in the framework that we're leveraging for our login. You have your replace with your Google account. You have a password. You don't need to send anything into that third parameter, your app name, and then that will give you a login token. So it's easy as setting the token. That's the device token that you got earlier. Send an ID, which is your collapse key, so to speak, in Google terms, and then you set data, which is just I accept an array in this. Basically, it gets transferred out as data dot key name, which is the value. You'll get all that inside of your application and you can send it. So the data there, my example is specifically focusing on like, hey, I'm going to give you something in your notification window. I could send an ID through here that would go and fetch additional data, do all sorts of different things with that. So the data can be anything you want.
Then you can continue to send using the same token all day, or
Kind of. You can. You won't want to use the same token. That's the device token. So you said
the login token.
Oh yeah, the login token. You can use the same login token. Yeah, that's what we do. We fetch the login token right away, and then we sit there and we cycle with it on loop through Gearman. Actually, Apple push notifications. You get 256 whopping bytes. So you don't get a lot of space there. So Apple's a little bit more frugal. All third-party application vendors send lightweight messages again. They make no guarantees about delivery or the order. See a trend here, right? Application running on iPhone and iPad device doesn't need to be running. The one difference with this is you have to make sure it adheres to strict JSON. If it doesn't, then it's not going to be great. but it is abstracted away from us and how we're going to be using it with this Zend mobile push library. The messages can also be sent in batches, so C2DM leverages HTTP to send theirs. With Google, you're actually leveraging a token. I mean, not a token, you're leveraging a socket. Within your socket, you have to send it through as many messages as you can and then you have to disconnect. They also have a feedback service that they monitor to see if you're listening to it. What that's going to give you back is any devices that may have said, I don't want push notifications anymore, uninstalled it, the device registration ID no longer exists. So you have to listen to that to make sure you're not sending to devices that don't want your stuff. So if you're going to do it, you have to have an SSL certificate and a key from the provisioning portal. After you have that done, you're going to need, your provisioning profile needs to be utilized for the application. There's a push one, and there's also your main one. So you have to install a certificate and key on the server. In this case, you need to make a PEM certificate out of it so that you can actually handle it within your application code. So they're a little bit more stringent on how everything needs to be created. These things from the provisioning portal expire, I think like once every 3 months. So you have to regenerate them quite a bit. But here's kind of how this application thing works. It connects, gets a token, they generate a token package, so you generate the device ID, encrypt it, send back the token, you eventually get the token so you can send out your message. So the application is going to grab its registration, an application called register for remote notification type method. The delegate implements the application did register for remote notifications with device token method to receive the device token. Passes the device token to its provider as a non-object binary value. That's a little bit important. Right? The notification by default, this just works based off of the payload for synchronizing. You have to implement this on the launch. So when you're sending data through it, you're going to get your notification, say view or whatever, being passed data to an additional process within your iPhone or iPad or iOS app. So this is just the sample code of registering for a push notification. You know, I really love the length of this. That's my favorite, like, long function name. Like, God knows my code, I have to do something about that, but it's all right. So we'll just continue on. You can find that online, whatever. The site will also be online later anyway. This is how you're going to handle the remote notification. So it's finished launching with options. Right, that's your main function there. Now you can start downloading from the provider. You set your application icon badge to 0. So make sure you always reset your badge when you open up the application. If it's already running, you can do different things on it. So your application is already in the foreground. You really want to show them the message. You can say, no, I don't want to. You don't have to display it. Continue on. Instead, you can update the badge number, do a variety of different things. But most of the things that actually happen with the push notification in the iPhone, you actually handle once somebody does some form of action on that notification. So implementing the server, some limitations. There's a funny story. Don't send too many out at a time, like 100,000. You should also implement the use sleep so you don't spam their server too fast. Our business owners had this great idea of saying, hey, maybe we can, for our holiday campaign, send out a bunch of push notifications to our users. Like, you shouldn't do that ever. That's bad.
Not like spam points.
Oh, yeah.
If they don't want to see it, I don't want to see it.
Exactly. But, I mean, the worst part about it was that, you spam your users, like, if one of the applications sent me a push notification to say, hey, go buy our Pro Edition, I'm going to go uninstall that app. I don't want it on my phone. I don't want them to sit there and message me bull crap stuff, right?
Big into GOCs as well.
Yeah, it is, but, do business owners listen to that? Exactly. So, if you're sending through a lot of push notifications through it, make sure you use sleep. Don't try to send them all at once. Kind of batch them in slowly. Otherwise, they'll continue to respond to you like they're being received and sent, but what actually ends up happening is that they just start ignoring them. They just kind of pass it to deaf null, so you don't have no more push notifications for a while. think it took like another day or two until like we were finally seeing our push notifications get sent again. So that was fun. That's my funny story. Ultimately, I won the conversation of you shouldn't do that, and how they're not doing it anymore. So this is how the server works. Provider gives a message to APNS, notification, yada yada yada. Same idea. That's how you set it from Zend mobile push. You have to set the certificate. You can also set a certificate password, so you had a password on your key. It allows you to actually pass in a password as well. But in the most brief format, you set the token with the APNS token, you set an ID, set the alert, set the badge, set the sound, and send it. You can do more advanced stuff within there. They have kind of a more extended push notification format where you can send custom data to it. And that is handled through this, but I don't think they show it in my slides here. If you're doing the feedback loop, it's really, really easy with this. You get a token, and it's going to give you the time that that token kind of came up as. They don't give you a reason why it hit it. It's just that you can't send to this device anymore. And they'll give you the timeline as well as the token, so that if you actually see that token come back through and register later, you can actually say, yes, I want to use that token. The main key of it is that somebody might say, no, I don't want it anymore. You tried to send them a message right before you got it. Then they put you on the feedback list, and then maybe they're like, oh yeah, now I want to receive it again. Maybe 5 minutes later, but you already looked at the feedback loop, but you saw that other message come in, so you want to look at the request time to make sure that you're only updating and removing people from your list where their time from the app push notification server is greater than the registration time. Makes sense? I know that was a lot of words. Okay, Microsoft push notifications. I'm not sure if they're going to find market share.
They've given away all the phones, haven't they?
Pretty much, they have, but they've got Nokia now, which is only building phones for them. And maybe there will be a difference, but I don't think they really care because they get a share just about out of every single Android phone sold because of their whatever. I hate IT. I just freaking can't. I can't stand the software patent industry and how you can kind of force companies to pay you money for something that you could have built in the first place because you had some stupid various crap patents.
Well, we had the idea 17 years ago when we couldn't do it.
So, well, you're still not doing it now after 17 years.
Right,
So,
I mean, that's
yeah,
the way it works,
that's
right?
the main purpose, right? So anyway, Microsoft's not going to go away. They'll continue to build on their mobile platform. It's not going to go anywhere. They get money anyway through Android, so they don't really care. But anyway, same spiel as every single other one. They have 3 different types of messages, which is a little bit different. They have tile, toast, and raw. Tile's going to show a tile on the phone. Toast message is going to give you like a simple alert message on the phone. Raw is going to basically say, I just want to send raw data to it and handle it myself. They have some weird limitations. You get 1 push channel per app. So their URLs are called push channels. It's just kind of another way for them to try to make something sound more complex. You have 30 push channels per device. So if they have 30 applications already that have registered for push notifications, you're not going to be able to get yours to register because they're already using them all. You have additional adherence in order to send messages. They basically want you to do all sorts of crazy stuff. You're invited into their agreement. You have to be able to have a log out. Unregistration flow, all sorts of various things. So if you want to send more messages, by default, they'll let you send some messages, but you can reach that cap really fast, and you have to register with them in order to get quote-unquote, unthrottled. So you get a 3K payload and a 1K header. So if you really want to send a lot of stuff to Windows devices, you can. So if you want to send that Word document you were talking about earlier, there's your opportunity. So if you're going to implement MPNS, you have to upload a TLS certificate to the Windows Marketplace. This is how you basically register with them to get the unthrottled version of it. By default, you get the throttled version. It's fine. Key value usage of TLS certificate must include client authentication. You have to have a CA authority. It stays authenticated for 4 months, and then you have to regenerate it again. So every 4 months, you're doing more maintenance on it, more maintenance on it, more maintenance on it. Service name. the common name found in the certificate is subject value. So like they're just making it a little bit more difficult to get your things secured. And I mean, TLS isn't really going to give you crap here anyways. But anyways, you install the TLS certificate in your web service and enable HTTP client authentication, and you're set to rock finally. So we all saw this diagram earlier. We'll just continue to work. This is how you register for push. You have different types of versions. Like I said, you have raw, you have codes, and you have tile. So if you're going to do raw, you basically don't do anything with it. So I've commented out things that are relevant, and basically we'll show you how to do every single thing that you want to do here. So it's pretty clean. It's not bad. It's probably one of the easier ones to implement. That's one thing Microsoft did well, was make it as easy as possible to register for. So that was a nice point. Callbacks for notifications. This is where you have to handle the different types of messages, right? So if you want to show something in the message inbox, that you receive notifications, shell post notifications, dialogues, yada yada yada. Microsoft has extensive documentation on their push library, which is really, really nice. They have sample applications for every single one of them. If you have any questions with it, you're going to be able to find the answers immediately. Whereas some of the other ones you have to poke around a little bit more. And if you're trying to do it on BlackBerry, you might as well get yourself a shovel, gravestone, and keep digging, because I don't know, everybody seems to have a question on it, and nobody seems to be able to implement it. So here's a raw message. It's really ugly. You have to have a proper XML message for the raw message, which is really fun. Like, get into the 21st century already. Not everything is XML. I'm sorry, your Windows applications and definitely Office run 3.1 version of Office still, because if your XML file fails, it looks like 3.1. I don't know if any of you had that experience, but it's quite interesting. It's just a glorified ribbon based out of XML. So that's problems partially XML. It's just failed. It's funny. Post messages, same thing, except you have now a title and you have a message. Unfortunately, their push server isn't smart enough to know the difference between the devices. So you need to keep track of if you have a device that's Windows Phone 7.1 or higher, so that if you want to send additional parameters. Not so much fun. They should be handling that for you, but they don't. Title messages, same thing, except it's even worse. You have a lot more attributes that you can send for 7.1 or higher. Still, yes, they should probably change that, but anyways, it's pretty easy. Pretty simple. The set title ID actually just basically says, this is the action I want you to open when you actually click on this. Everything is stuff rooted, manual file or whatever. BlackBerry push notifications are not supported. We'll talk about them anyways.
So they work as well on this phone as they do on any of them?
Pretty much. I mean, unless you're RIM or some company that has a massive investment of millions of dollars into their app, I'm not quite sure how they do it. I knew one guy that built them, and he's like, yeah, I'm glad I'm not working on those anymore. And he was a big Java guy, too. He hated it. So, it's kind of funny. Same thing, you can send an 8K payload to their push notification service. Talk about a big document. I'm not exactly sure why. They have their own standardized protocol. WASP 2.2. So, mileage is going to vary. The protocol is a little bit easy to understand. How you actually register with the BlackBerry service and everything else is really, really awkward. You have to install all these utilities. It doesn't really work on Linux. If you have a virtual machine, you can't get virtual machines inside of a virtual machine. So that's where my mileage kind of stops. Anyway, here's kind of the process again. Remember the graph or diagram or whatever they call it. They have a sample application. You want to ever try to get it working. Deep within their push SDK, many of which are pre-compiled. Their documentation is hard to follow. The sample isn't exactly straightforward. I mean, they're including like 25 different Java files. You're poking around each one of them trying to figure out what the hell you actually have to do to actually make this thing work. And you install the SDKs in this VPSS push SDK low-level push sample enabled app, and unzip the push sample. So the sample push enabled app 1.1.0.16 sources.jar. Yeah. So anybody has experience with BlackBerry push notifications, I would love to.
Well, I say currently unsupported. If you can do all this stuff and work anyway.
Well, you can do I've kind of tried to rewrite somebody else's library to make it work. I'm not sure if it does work. I've never actually been successful in getting a BlackBerry application running, especially from their samples. So I made a really sloppy port of this original source thing because I did a more generic version of this before using different libraries and such. But anyways, you have to register for BlackBerry. You can go there. Try this library out. It might work. It probably won't. And if you actually have an application that can receive push notifications and you send it to me and I can play with it, then I will make it work. That's my guarantee. So again, I've never tested this, and that's why I look so freaking awful too. I'm like, you have a PAP message, BlackBerry message, you add it to an email address, you push it out. I'm not sure what the response will actually contain, so didn't really look into it too much. So I'd like to get them in just because there still is a big enterprise market out there, but unfortunately I'm not so certain on BlackBerry development cycle, and they're not very helpful with the developer either. So I'm hoping that once that framework has that mobile push library, they might try to contribute something to it.
There was a thing earlier today, and they said that Honeywell still has 5,000 BlackBerries that maybe belong to the executives that really like to do things. So.
Yeah. It would be awesome. Fortunately, they don't support the developer community very well. So anyways, the future resources and finally will be done, right? VF2, Zend Framework 2 is going to come out. I've got to rewrite it, but I've got a lot of contributions to do with it. BlackBerry, it needs a implementation. I'm not sure about how to get there. So maybe they'll start working with the developer community a bit more after they realize that they're really making no more money until they can change their fundamental ideas of how they talk to people. Some resources, you have all your main sites. You have the Apple Push Notification Service. You have the Google Cloud Device Messaging one, Microsoft Push Notification one, BlackBerry Notification one. Yeah, they have the Push API and JSP. They have a specific page of the documentation for it that tells you absolutely nothing. And then the push client. I referenced two spots here because it's in the trunk of Zend Framework right now. I maintain it on GitHub as well, so I'm maintaining both right now until it gets officially released. And BlackBerry might be broken, but it's better than I thought last week. I am. Questions? It's a lot of information.
Could you maybe name a couple good examples of the usage of push notification that you've seen that were damn, that's really nice?
I don't think I ever see a push notification say damn that's nice. In particular. Gmail uses it in the background. I think Gmail does a pretty good job of their notifications. Do we use it? I don't think we do a good job. Some of the workflow stuff is hard, and you have to design your app around it well. So, if you receive a push notification, you should probably bring the person to where they want to go. Easier said than done. Most of it is, one of the things we can be doing better if we were leveraging local storage in our app, but we don't, is to send down IDs when something changes, or periodically send something down, ping the device to go update everything. Right now, we don't do that. It'd be nice to, but we don't exactly have the resources to full-time dedicate our resources on apps right now. But that's kind of some of the more general use cases. You're either trying to tell somebody something, or you're trying to update something.
So it can, sorry if I don't understand this, but it could just be used to sort of trigger the app to do other things because it's so small that the user wouldn't see alerts. Is there kind of a thing there?
In C2DM, yes. In MPNS, yes. In the APNS, I don't believe so. I think you have to actually take action for it to actually do anything. Yet again, I don't have a map or play with it too often, but the time when I was trying to play with it, I couldn't see a way of synchronization without actually leveraging the custom data when you press the actionable button from the alert. you can just update the badge. Maybe you can. I don't know.
Okay.
Should be possible. I hope.
So, how long has this library been around, and do you know of any other groups that are using it, or?
I've got a few forums on GitHub. I wrote it in November. Maybe last year. It was before ZenCon or whatever, so I don't remember when that was anymore. My memory's starting to fade. No, it wasn't November, because ZenCon I actually talked a little bit about push notifications in a different way before I actually had this full library built. So it's, since November I've had it, I've verified everything's working, got accepted into the Zend Framework trunk. Just waiting on a Zend Framework 1.12 release, which there's some unit test failings that I've got to fix those, and it's not exactly the biggest priority in the world either.
So are there any like other open source like full app examples that are floating around out there?
Probably. I know Google has their some of their application examples, specifically like the Chrome 2 phone app that's in their SDK. iPhone, I'm not so certain. I think they have all the code there. I'm not sure if they have a sample app. I thought they did at one point, but I've never been able to find it again.
I think the WordPress app for iOS
Anybody else? Y'all done listening to me banter about weird shit for today?
Well, I mean, I guess like, would there be a way to not use these corporate providers, like if you didn't trust them because they're sketchy? Like, are there other types of push notification frameworks, like, or?
Urban Airship has one.
Hmm?
Urban Airship has one. That's really just doing a pub sub model behind the scenes as well. You can, on Android, you can write a service that just constantly runs in the background and pulls. I'm not exactly sure how you do that on an iPhone.
You know.
Okay, there you go. You can't.
Okay.
They don't allow you to do that. For Windows Phone, I think you might be able to. All right. Any more questions?